Okay, good morning, everyone.
Good morning, Professor.
All is good? Okay, so here's what we're going to do today. I'll just do one more sorting exercise or, algorithm, and then we'll spend the rest of the lecture talking about the exam, answering any questions that you might have. All right? So last time we started talking about searching and sorting a list. Yeah, so why are we doing this? Because these are very important problems in computer science. We always do this, right? Most applications do some sort of searching or sorting over a list. Not necessarily integers. We're playing with integers as an example, but in principle or in practice, you could be using sorting any list of objects. Yeah, these could be even from a certain class or a certain type that you've created. There is one exercise in the assignment about this. Okay, so the second reason is that they're really a good case study for complexity, to understand complexity, apply complexity analysis and so on. So the last time we looked at linear search, binary search, and then we looked at one sorting algorithm, which is the selection sort, which tries to pick the minimum element and put it in its right position in the list. Yeah. Now we'll look at the second algorithm for sort called insertion sort. And the idea for it is it's really the sorting algorithm that we use when we're sorting a hand of playing cards. So that's kind of the algorithm you apply without really noticing that it is insertion sort. So how does it work? You start with an empty left hand. So assume that all the cards are facing down on the table. You have a deck of cards on the table, and you're drawing one card at a time, and you're going to sort them in your hand. Yeah. So your hand is initially empty. The left hand is where I'm going to be, sorting the cards, and it's initially empty, and all the cards are facing down on the table. You remove one card at a time from the table. Okay. And you insert it in its correct position in the left hand. So, since your hand was initially empty and you picked one card, it's going to be just, put in, there's no position really, right? It's going to be put in your left hand and that's it. Then the next time you pick a card, you have to, compare it to the cards in your hand and see where it fits. Yeah. So you basically, that's what I mean by in its correct position in the left hand. Okay, so how do I do this? I compare it with each of the cards already in hand from right to left. That's one way to do it is, okay, I have the cards in my left hand, they're already sorted. And now I'm picking a new card. I'll go from right to left, right, on the sorted card and see where it fits. So if, from right, if it's bigger, then I move to the previous card, and so on until I find the right position and then place the new card. Okay, and then the cards in the left hand will be sorted, and I keep repeating this until I finish all the cards, right? Okay. So let's see an example with some concrete lists. So I have the same list from last time, 5, 2, 4, 6, 1, 3. It's obviously unsorted, and I want to sort it using insertion sort. So here's the first pass, right? I assume, right, that 5, I have the list like this. So I'm going to assume, right, this is my list. I'm going to assume, right, that I picked 5. So that's really the first step, is picking 5 from the deck on the table, and it's going to be in its right position. And now I'm looking at 2. I picked 2, the next one. So the next card that I picked is 2, right? So I'm going to check 2. Is 2 greater than what I have so far, right? So is 2 greater than 5 or not, right? So should I swap 2 and 5? Yes, because, right, so I have to push 5 here, right, instead of 2, and place 2 before it, right, so that it's in the right order. And now I have 2 and 5 sorted. And now I pick the next card, which is 4. Okay, and I have 2 and 5 already sorted. I need to put 4 in its right position. So I'll go from right to left, right, like this, and I see 5. What is its relation with 4? It's larger, so I need to push 5 one step, and then move to 2. Compare 4 and 2. Oh, 2 is smaller. This means that 4 should be placed in between here, right in the place of 5. Then I move to 6. So now I have 6. Okay. So now I'm looking at 6, and 2, 4, and 5 are already sorted. These guys are already sorted from the previous pass. So I'm gonna try to figure out where 6 fits. I'm gonna compare from right to left. So 6, is it greater than 5? Yes. So I know that 6 is in its right position because all the elements before 5 are smaller. And if 6 is greater than 5, then it's greater than all of them. So it should stay here. So I'm not gonna do any swaps. Then comes 1. Right? This is the sorted list so far, and 1 is the next card. So what do? I'll compare 1 to 6. Okay, it's smaller. This means push 6 one position. 1 to 5, 1 is smaller, so I push 5 one position. 1 is less than 4, I'll push 4 one position. 1 is less than 2, I'll push 2 one position. That means that 1 eventually, all of these elements will be pushed, and 1 will be placed in the beginning. Finally, I have the 3. Right? So now the 3, I'll compare to the elements in my left hand that are sorted, these guys. So I have 3, it's less than 6, so I have to push 6. It's less than 5, so I have to push 5. It's less than 4, I have to push 4. It's greater than 2, this means you can insert now 3 in this position. Okay? And now I have all the list sorted. Again, this is the mechanism you do if you're playing cards, if you're trying to sort, playing cards in your hand. So far, so good. Any questions? Okay. Let's see the pseudocode, and then we'll discuss its complexity. It's not complicated. Again, you don't need to memorize this at all. You just need to understand how it works. Okay, so here's one implementation of insertion sort. So I'm going to loop basically a length of L minus 1 time. Why length of L minus 1 time? Because I have, right, I assume the first element is, I have only one element on my left hand, so it's going to be in its right position. Okay, so I'm going to keep track of an element called current. That's the current element, the element that I'm looking at. So that's really going to be 5 in the first round, then 4 in the next round, then 6 in the next round, and so on. Okay, so I'm going to draw the elements here. 5, 4, 2, 6. Let's say 8, 1, just for the sake of it. Okay, so first time current would be the 4. Okay, and now I'm saying, okay, have another loop over all the elements that have been already sorted. This happens to be only 5 so far. So I'm going to do while, right? Basically, I is greater than 0, so I haven't reached the beginning of the list. And, right, my elements, right, that I'm comparing to in the already sorted sublist is greater than my current. As long as they are greater than my current, push them, so push the 5, right? So L of I is equal to L of I minus 1, and decrement I by 1 to look at the previous element. And you keep doing this until you hit an element that is greater than, that is smaller than your current element. This means you can stop pushing, insert it, right? So that's the insertion. And move to the next round, right? So the next element, so to the 2. Okay, so now the 2, you would have here 4 and 5 in the right order. And all you'll have to do is to say, start from, 5, compare it to 2. Since it's greater, right, you will increment I by 1. You will push 5 to the next position and decrement I by 1. Look at the 4. Since it's also greater than 2, you will enter the loop. You will push the 4 to this position, and you're going to, decrement the I. And then you will hit here, you will exit this loop because I is now equal to 0. And so you will just put L of 0 equal to 2. So 2 will be inserted here. Again, you don't need to memorize this code. There is various ways of writing this code. What I want you to understand is really how it works. The code snippet is also, or the script is also uploaded on. Questions? look at the code. Again, I'm gonna remove the annotation. Try to read it and understand what is it doing, and then you can ask questions. Okay. Yeah, the second loop is a little bit different from what we're used to because it's working from, I equal to the current element all the way till 0, right? So it's going like this, where that is. Okay, questions? So this is really, if I want to explain it again, this is picking the card, and this is comparing the card, to cards on your left and pushing, right? So it's on left, not on right, and push. Okay, before we get into the complexity, let's run it. I'm gonna do insertion sort here, just to make sure that it's working. Okay, so I'm gonna do Python insertion py, and as you see, it sorts the elements right in its right position. So the list was originally 3, 2, 4, 1, 5. What it's going to do is it's going to sort it. Any questions you have about this? Okay, good. So let's talk about its complexity. That's what really matters the most here. Can anybody tell me what is the complexity of this algorithm? The big O of what? How many, comparisons or operations are happening in this algorithm? I have 2 loops. The first loop runs order of length of L. Okay. So length of L. Yeah. Right. So that's the first loop. I see that some people already are ahead. The second loop, this one is a little bit tricky. The while loop, right, runs, what is the worst case? Again, remember we're doing, the maximum. So in the worst case, how many times will it have to run? Remember the second loop, its job is to, compare right, is to compare, the current element to all previous elements. Right? So this is what it does. This is the while loop. It starts from here, compare all the elements. So in the worst case, right, I will have to go all the way back. So for every element, right, that I have, I'll have to go all the way back, right, to push all the elements and put it in the beginning. So if the list is sorted in reverse order, particularly, what is going to happen is I have to compare this to that and this and this and this, and then put it in the beginning. And each time, right, I move to the next element or the next card, I have to go to all the previous elements. That's really the worst case. Yeah, if the list is sorted in reverse order, right? And that would be also then of order of length of L. Right. If I have nested loops, one is length of L, one is length of L, then it has to be big O of length of L squared. One list is in reverse order. Yeah. So let me erase. Okay. And now, what do I mean by reverse order? I mean the following. Let's say the list looks like this. 8. Oops. Sorry. 8, 6, 4, 3, 2, 1. Why is this the worst case? Because again, right, for 6, I'll have to compare it to 8 and push 8 to put 6. So now I would have 6 and 8. And then 4, 3, 2, 1. And now when it comes to 4, I'll have to compare it to both 8 and 6, and push 6 and 8 and put 4 there. And then I have to do the same for 3. Compare to all 4, 8, and 6, and push all of them and put 2. Okay, so that's really the worst case. The worst case, the maximum I'll do is I'll have to go through all the list, or order of all the list. Okay, just a teaser. You're not supposed to, to care about this, but what is the best case scenario? Can anybody tell me what is the best case? So this algorithm could run faster, slightly faster. When? The list, when the list is sorted, as Khaled, exactly, right? As Luai and Sergio and Khaled, exactly. When the list is sorted, this loop will immediately, exit with just one comparison. Right? So if I look at the list like this, okay, and let's say the list was like this: 1, 2, 4, 5, 6, 8. Okay, the first time the while loop runs, I'm looking at 2 and I'm comparing it to 1. 2 is greater, right? So this condition is not true. So I'm going to exit the loop. The next one, right? I have 4. I'm going to compare it to 2. 2 is smaller, so I'm not going to do anything. So every time this loop runs only once, and the best case complexity, if a list is sorted, is going to be big O of length of N. Okay, so you're getting the sense of this. For this course, we only ask you for worst case complexity. You always think about, what is the maximum number of iterations that are going to run for a loop. That's all we want you to know. But it's good to know what it means worst case versus best case, because you're going to see this in other courses. So in the algorithms course, for sure, if you continue with computer science or computer science courses. Okay. What is that, Jad? Yes, if all the numbers are in the right spot. Exactly. Excellent. Questions? Okay. We have one more sorting algorithm that we'll do on Monday. It's not complicated, but I think just because I don't want to overload you today, and also it's a nice algorithm, and the analysis is a little bit difficult because it's a recursive algorithm, and we haven't done talked about recursion or how to analyze recursive algorithms. So we'll postpone it till Monday, and that would be the last thing we cover. And then on Wednesday we'll just wrap up the course. Take some feedback and answer other questions that you might have. Okay, but you can start on the assignment definitely today after the exam. I know you're busy with the exam, or tomorrow. You would have only the question on merge sort. So I think 2 questions in the assignment that you wouldn't be able to answer until Monday. Okay. Excellent. All right. How do you feel? So you can turn on your mics. You can, first of all, we can discuss in general. Are you feeling anxious? Something like that. Then I can take specific questions that you might have. No, sorting is not on the exam. Yeah. So basically, not any this slide set. So searching, linear search, binary search, and sorting are not part of the exam. Yeah. So everything that is related to assignment 10 is part of the relevant to the exam. So the one that you submitted on Monday. After that, right, the things we've covered on Wednesday and today are not relevant to the exam, of course. Okay. How many questions are in the exam? There are 3, and we're giving you more time. So we're giving you 75 minutes. But again, it's going to be sequential. So my advice to you is the following. I'll answer your question, Christine, but let me finish. So you have 75 minutes, 3 questions. Spend 25 minutes on every question. Assume that every question is an exam on its own. So you have 3 exams today. First exam is 25 minutes, and it's going to run out. And then you have another exam for 25 minutes. Then you have another exam for 25 minutes. Yeah. So really don't spend an hour on the first question trying to get it completely right, and then you have no time to deal with the other questions. Yeah. Just look at the clock on Moodle and you say, okay, after 25 minutes, I move to the next question. Yeah, that would be my advice to you. So up until the last assignment, yes, Christine. Will you import from another class? You wouldn't need to, yeah? So you wouldn't need any imports. But in principle, you will have exactly the same environment. So like previous exam, so you will be able to run your code, check it. There are test cases that you could check against. So it's more interactive than the first exam. Other questions? The difficulty same as the assignments. I would say for me, it's easier than the assignments. So for me, this exam is definitely the easiest among the three that you've seen so far. And that's my impression. They grade your logic? Yes, of course they do. Yeah, so they don't care. You might get 100, even if you or almost 100, even if your program doesn't run correctly. Yeah, important thing. So they read every exercise or every solution and try to, there is a very detailed rubric that we give them to kind of assign grades. In fact, we don't ask them even to run the code. Exam 2 was difficult, you thought? Even after solving it, so even after, yeah, the recursion was difficult. I agree. But recursion in general is a difficult concept. So even when you're an expert in computer science, I've been programming for years. Recursion is something that is sometimes not very natural because you can't really imagine it in your head. But once you take a little bit data structures, so the next course, CMPS 12, if you continue in computer science, and I hope you do all, unless you're from a different major, of course, you will get the hang of it more. Yeah, so you will understand how it works exactly, and you'll be able to deal with it. When you saw the solution, you cried. Why? You would have never thought of it. Okay, but I know it was difficult. I know it was relatively difficult compared to the other exercises. But again, right, try to get the logic working as much as you can. Yeah. So a lot of people actually, once they solved the exam, and the assignment, they felt right that just the stress of the exam and so on. So we know that. Anyway, the average of the previous exam wasn't very high, so it was less than the first one. So you don't have to worry too much if your grade was not that high. It took you 30 minutes to solve each of the 3 problems for the assignment. Okay. Yeah. So this time, trust me. This time the questions do not. I mean, we could have done the exam for 1 hour. It would have been completely sufficient. But we thought we wanted to be nice with you and allow you to relax a little bit, so we gave you extra time. So I think the average for the exam 2 was 69 or something like this, if I remember correctly. Yeah. But that's normal. So even just don't feel like because you're online, you're learning online, that you're not, you're different or you're doing worse than when students were on campus. This is not the case. So really, I mean, the averages are typically the same for the exams, whether the course was completely online or not. So we don't see a significant difference from previous semesters. Raise is something that we might have to do. Yeah. So we're being very open with you. So there is a chance that there will be a raise. What we do is we calculate your grade completely at the end for all the exams and the assignments, and then we see if we need to do a bit of a raise for the whole class. Then we also look at borderline cases, so problematic cases, and so on. So we really study the grades very well before we post. Okay. So will the exam focus on classes mostly? Yes, but again, right? Remember that this is a programming course, so you will even with classes, yeah, you're doing functions to do certain stuff, so you need to really know everything, yeah, that you've learned. But yes, I mean the focus would be on classes more or less. Okay. Are raises all or nothing, or is it possible that only some students get raises and others don't? No, so everybody, definitely if we're doing a raise, everybody gets it, but there are certain cases, right, that we might want to adjust in addition differently, yeah, and that really because there are, borderline cases, somebody who, for instance, had a certain issue, missed an exam, so we look at all of these things, yeah. Yes, Christine, about what? For instance, right? We're not going to fail somebody if he gets 59, yeah, or 59.9. That would be ridiculous. Yeah, so we have to really look at it. What is Manacher's approach? Mm-hmm. Okay, let me open the last assignment, yeah, so that we're on the same page. That's 200, fall 2020, assignments. Assignment 10 you're talking about. Yeah, okay. So the longest palindrome, yeah, okay. Okay. Remember by noting that all odd length palindromes can be built starting from a single character inside the string and expanding the palindrome right and left if possible. Even length palindromes start with an empty string between two characters and expand right and left if possible. Using these observations, drive and write an algorithm for finding the longest palindromic sequence in a string. Okay, so yeah, what is the issue with this? So first of all, right, the exam is not going to be, difficult like that. So I know these two exercises were particularly different. The power set as well, but the power set we've discussed in class. Longest palindrome and the next one, it's revisited version, are definitely very difficult exercise. Yes, complexity, yes. Yeah, so we should know. I mean, if you write a function and it has a loop, we might ask you, put what is its complexity? Yeah, something like that. Yes, you answer in comments. If there are complexity questions, we will tell you exactly how to answer them. Okay. Again, don't panic. Get into the exam, relaxed, just tackle it one problem at a time, and try to see this as if it's a challenge or an exercise. I know you get stressed from exams and everything, but try as much as you can to relax. I think so. But don't waste too much time writing comments and stuff like this. Yeah. So yes, if you have time, put on doc strings or comments to explain your logic. But these are all going to be very small things. So whether it's a class or it's a function to do something, so it's really easy to understand what you're trying to do. So I mean, it's a loop. Yeah. Obviously, the loop is going to run over these elements and so on. Yeah. So, of course, it's always better to put comments, but don't waste too much time. What I want you is not waste too much time from the exam by putting a comment. Yeah, so don't put comment with everything. If you have time after you finish the question, or if you feel you have a couple of minutes you want to spare, you can add comments to explain what you do. Yes, before the final, what happens, Christina? Practice questions. I can try to look up. I don't have particularly any practice questions, but I'll try to look up if there is any good resource online I can share with you where you can do some exercises. A good practice would be to kind of solve the assignments again from scratch. So really kind of particularly start from the end going up. Yeah. And try to solve this exercise again as if it's really an exam. So you time yourself and you try to solve it. This is a very good practice. Okay, but I'll try to look something up if there are certain resources. If you have access to also previous exams, you might want to do that. Yeah, that's also a good way to exercise. But the problem is with programming, it's really always something new. So you're not gonna get something that you've seen before to an extent. So it's really a matter of you know it or you don't. Yeah. So, of course, practice makes perfect, but it's not like any other course where you can study for it, and the more you study, the better you will do in the exam. Yeah. It's like writing an essay or drawing a sketch or something like this. Yeah. It's really on the spot, do something, and it just has to be in. Yeah. But practicing programming in general is something that helps you, of course, get better. on the long run. Other questions? Would I solve the longest PAL question? Let me see. I should have the solution somewhere. I'd not prepare it, right? So I have to see how it does. Okay, give me a second. Was it in recurrent? No. What is it called? Longest? I think it was in what is with the previous sorting complexity, maybe. Yeah. Okay, let me go here. Maybe it was here. That's classes. Let me search. Palindrome, it's called. Okay. And there's so many of them. That's in lecture 4 now. That's this and tuples. Functions. Maybe that one. Let me see. Yeah. Okay. So I have to remember what the code does. Okay. So what is the longest palindrome? So let's see read the question. Okay. So write a function, right? Longest palin that returns the longest substring in a string that is a palindrome. Meaning what? Meaning it can be read from left to right the same way as from right to left. A brute force method for finding the longest palindromic substring is to loop over all possible substrings and keep track of the longest one encountered. To loop over all the substrings of a string of length n, you may use a nested loop with an outer counter from 0 till n and an inner counter from I till n. Okay, to generate the substrings s of t, st of I to j plus 1. Okay, uses palindrome function you wrote earlier. For example, the call longest palindrome returns xyz. Okay, what is that, Christine? What do you mean by the short codes are faster though? Okay, yeah, so you said comments. I'll go back to the palindrome example, but let's see. Do we lose marks for using built-in functions for Python? No, you don't. Yeah, unless we explicitly ask you, Christina, not to use it. Yeah, so let's say we're asking you write a sorting algorithm to sort a list, and you come and say, okay, l.sort, then of course you use question. But in general, right, if we don't say anything, you're allowed to use any built-in functions. Yeah, exactly what Jawad is just saying. Yeah, so exactly saying, let's say you find a maximum element, like the maximum element in a list, and you kind of just use max of f, right? Then you would use question. Okay. All right. So let's see. I have this function which just tells me whether a string is palindrome or not, right? That we've written before. That's a recursive function. And now what I'm doing is the following. I'm looping over all the possible substrings. So I'm looping over the length of the string s. So if s was, let me see here, if s was a, b, b, a, c, and let's say d here or something like this, I want to get ABBA as the longest substring. So I'm going to do a loop over every element in the string. So I have two nested loops as the algorithm is saying. And then I'm picking, the substring that starts with I. So eventually it starts with, 0, 1. So that's the first substring. Then I have a substring which starts with, D and A, then D, A, B. I'm generating all possible substrings, right? That's what I'm trying to do. And this is what the loop is doing. That's written in the assignment, so we really don't have to think about it at all. You're looping, right, and generating all possible substrings. Okay? So that gives me all possible substrings because I would start the second time from A, and then do A B, A C, and so on. Okay. And now all I have to do is check, right, if this substring, right, that I'm currently looking at is palindrome using this function, then I keep track of its length. So I check what is its length, right? And if it's greater than my current maximum, then this would be the maximum, palindrome that I've seen so far, or the longest palindrome I've seen so far, and I keep track of it, right, in this maximum subvalue. And if it's not, then I don't update it, right? So this palindrome is smaller than what I've seen before. I've seen a longer palindrome before, and I keep looping like this until I finish all possible substrings. Okay, Mariam, does that make sense more or less now, or? The observation from the next question. Okay, let's see. So the revisited, right? Let's see what it says. The asymptotic complexity of the algorithm for finding the long values in a string length n can be improved, and this program considered a more efficient algorithm than the one above. The alternative algorithm can be derived by noting that all odd length palindromes can be built starting from a single character inside the string and expanding the palindrome right and left if possible. Even length palindromes start with an empty string between two characters and expand right and left if possible. Okay, let's try to discuss this. I don't think I have the solution at the moment. I can present on Monday, but let's at least try to understand what this means. Okay. So it's saying the following, right? A palindrome can be derived by noting that all length palindrome can be built by starting from a single character inside the string. Okay, so let's say I have the same string from before. I'm going to use, D, and then ABBA. Okay, and then C, for instance. All can be built. And expanding the palindrome right and left, if possible. Even length palindromes start with an empty string between two characters and expand right and left, if possible. Okay. Okay, so I think what it says is the following, right? Just I guess, right? I have to double check this later, right? So if I have something, an odd, let's focus on an odd palindrome like this, yeah? This means the following: you start with a letter, and then you expand left and right and check. So you keep looping, right? So let's say you go to the middle of a string, you keep looping and see, am I getting the same character or not? Yeah. So if I'm looking at to get the even, the odd palindromes, right? I would start. So this one is an even, so that's why I wouldn't be able to apply this this property. But let's assume the string had ABA. Yeah. So I'll start here and then keep expanding. So keep going to the previous character and the next character, and continue as long as they are the same character. Right? So if that is the same as that, then I can continue. There is a chance that this is a palindrome, and I stop once I find two characters that are different. So if it was like C and D here, I would stop, and I know that this is a palindrome of length 3. If it's an even, I would start right with an empty string and repeat around. And I know this is not exactly very helpful in writing the algorithm, but I'll try to look at it and we discuss it on Monday. Yeah. So don't worry about it for the exam. You would not have anything slightly related at all. Yeah. Sounds good. Okay. Other questions? Okay, guys. So very, very good luck today. Again, you'll be as usual, proctor through your cell phone. So make sure, right, this is set up. Try to get into the room of your TA or of your proctor, right, few minutes before the exam starts to set things up and make sure everything is working. Okay? Yeah, good luck. If the internet went off, there shouldn't be a problem. All you have to do is once it gets back on and you're back online, just refresh the page. Should get you back where you are. You don't need to panic at all about this. Yeah. If you lose significant amount of time, just let your proctor know so we note this and try to either extend the time for the exam or take this into consideration while grading. Yeah. No, you don't need to end your life because Wi-Fi, like is off, right? That would be too extreme. So just chill about it. Wait until the router starts, and get back on track without being too nervous about it. And just if you lose significant amount of time, let us know. 10 minutes or something like this, or 5 minutes. Let your proctor immediately know so he notes this and he tells us. We're all together in a separate room, the professors and the TAs. So we have a contact with them to immediately troubleshoot anything. Yeah, I mean it's a horrible situation. You really, I feel very bad for you that you have to go through all of this without a good infrastructure. But hopefully this will either change soon, country-wise, or you'll get back on campus again soon, so that you don't have to do this. Okay. Yeah, just chill. I've listened to some relaxing music before the exam and just take it easy. And trust me, this exam is easy. Xanax is not what I'm saying, Christina. You're gonna put me in trouble. Yeah? No, I'm not. Don't take Xanax, please, unless you're on it already. Right? Yeah, I know you can. Okay. Anything else? Just remind me on Monday, please, to do the longest palindrome once we finish the merge sort. Yeah, so do merge sort, and then we talk about the longest palindrome revisit. No. I'm not gonna talk about Xanax anymore. This is recorded. I'm gonna put me in trouble. You too. Good luck today. Bye-bye.